Communications-Based Train Control. CBTC. How can we circulate with an increasing volume of cargo without disregarding our commitment to safety? This is a challenge for MRS Logística. We are on one of the world's busiest rail freight corridors, which crosses 3 states of Brazil: Minas Gerais, Rio de Janeiro, and São Paulo. Professional teams work on matching efficiency and safety. So the CBTC comes on the scene as a new reality that takes place on the MRS rails. But how does it actually work? In order to answer this question, let's enter the MRS Rio operation. This is the journey we are starting now. Train building starts here at the back office in Juiz de Fora, Minas Gerais, where the professional team sends to the railway yard the schedule of activities. The yard team receives the train schedule and everything starts. Maneuvering locomotives, train drivers ready to work, wagons coupled, and the train is ready to leave. Here, the CBTC comes on the scene. The station agent releases the train in the system, and this information goes to the Operation Control Center, the CCO, which returns composition data to the locomotive console in any MRS yard. The train driver activates the CBT system, confirming the train data and performing a system test, which guarantees a safe trip. Now we have everything set up. Let's go! Okay, now we are in motion. From now on, the CCO, which has been modernized and prepared to operate the CBTC across the entire network, will send our movement licenses until we reach the destination. The signals are being opened. The vital information are coming on board through antennas, and our train driver visualizes in advance what's going on, reducing voice communication with the CCO. On board, we have information about current speed and limit speed, position, track grade, curves, areas under maintenance, trains on our approach, besides the area where our current license ends and our next target speed. This information arrives on board through dedicated data network, controlled by Anatel. This ensures that we will receive information throughout our trip. Along the railway, there are several places where trains exchange information packages via Wi-Fi, transmitting telemetry data and collecting event logs. This way, the Maintenance Control Center, CCM, can control the operation of locomotives in any part of the network covered by the CBTC. Now, watch how the CBTC ensures our driver the possibility to act in advance in any situation. Notice this yellow line. It represents a warning distance, and the red one represents the stop distance. Due to the grade, train speed, train weight, number of wagons, the active brakes, and locomotive power, these 2 lines vary during train movement. So our train driver can safely go on, because he will be warned a few minutes and miles in advance about what will happen ahead. Watch in this simulation the movement of the 2 compositions within a particular stretch. Notice that composition A slows down because its warning distance entered an area that has not been licensed by the CCO. At this time, an alarm sounds aboard Composition A. Reducing the warning distance speed, it leaves the unlicensed area and everything is back to normal. Assuming the CCO does not release the next license, the warning distance will again enter the unlicensed area. The alarm will sound, and the train driver will slow down. Finally, the CCO releases the next license, and we are back to target speed. But now, notice that due to this reduction in the speed of Composition A, the warning distance of Composition B has started to reach the section where Composition A is. When this happens, the audible alarm sounds aboard Composition B. Now, suppose that for some reason the Composition B driver does not reduce the speed and the red stop distance reaches the section where there is a locomotive ahead. At this point, the system will take control of Composition B, which means that the train will stop by an automatic command from the system. The CBTC has broadened the view of our train driver, who can now identify possible events before they pose a risk to the operation. Now the information arrives on board, integrating the locomotive to the signaling system. We have also seen that the composition will be stopped automatically when it exceeds the braking limit calculated by the system at each point of the track. This causes the network to be operated more safely, allowing it to shorten the distances between compositions and increasing the system capacity. Now, we are able to answer the question from the beginning of our trip. How can we circulate with an increasing amount of cargo without disregarding our commitment to safety? Communications-Based Train Control, CBTC.